So welcome to week 8. I will put the link into our chat so that if you are not in Moodle, you don't have to find it. And we get to start a new topic. We're on B8 using data, which is mostly about averages and measurement, but as everything, we're going to do some things that you've seen before, some things that are new, and hopefully anything you've learned, but not that people explain to you about really why it works, you'll get all of that and be happy. So let's start doing that. As usual, for any topic, there's the books, which sections in the book to look at, a link to the same whiteboard we're using all term, all the best YouTube videos I could find, the not very helpful worksheets because I still haven't had time to make an answer key, although the answer key is now in the syllabus area. And the 2 different My Open Math topics at the very end after you've done enough practice in the textbooks. So you know the routine by now. We're in week 8. Okay, so we're starting by talking about frequency tables. And as a review, I want to talk about tipping at restaurants as a warm-up for our brains today. And we saw earlier that if I'm dividing by 10, then that's 1 decimal point scoot. If I'm dividing by 100, that's 2 decimal point scoots. And we had the rip block for right into percent, left out of percent. Will that ring bells? Do you want me to go back to the slide that had rip block and show you that again? Let's do that and get it more in your. Right.
Yeah, because you're doing on my computer over here.
What?
Also, like my face.
Right here, your name is showing on my computer.
On this. Okay.
Well, please play out this for
No.
Percent means 100. That's divided by 100, which means that if you're starting with 47 and you want to go out of percent, you go left twice, bonk, bonk, because that's the same as divided by 100, which is what that percent symbol means. Otherwise, if you want to go in to percent symbol, like you start with 0.05, you go right twice and then say, oh, it's 5%. The idea being that since the percent symbol and divide by 100 or 2 scoots left mean the same thing, if I take away a percent symbol, I have to do 2 scoots left to kind of replace it or pay for it or however you want to think of it. You can't change a number because I want to. So if I take away something that means 2 scoots left, I have to put in the 2 scoots left or I've changed it. And similarly, if I want to add a percent symbol to the end of a number, I can do that, but I have to pay for it. I just added something that's 2 scoots left, so I have to do 2 scoots right, so it comes back to where we started. And I haven't changed the number. So we called that rip block, right into percent, left out of percent. We did a few examples. Let's do a couple more, just because it's been a bit. So if I am wondering what percent is 0.38, am I going into percent or out of percent?
So, what was the question?
Which one do we?
Oh, I have the answer.
Yeah, I'm gonna start, well, we all know each other by now, I can just call it.
What was the first?
Are we going into percent or out of percent?
I I'd say probably out into percent.
There's no percent there, we're going,
I mean, out,
no, we're going in.
in, that's what I said.
So into percent format, we're not there yet, so we need to go right twice, and then we just say that that's 38%. Or if I said, what about 3.4%, how do I write that as a decimal?
Going in,
Now I am trying to get out of percent format into decimal format.
love,
Go left twice. If I scoot off the end, I need to put a 0 to like fill in the space.
So that's how you write it as a decimal,
Yeah, 0.034.
so it's not 3, because if there's 3 point, it'll be 4, okay.
I can't just take off the decimal the percent symbol without doing something else to compensate, so I
Yeah.
can't just write 3.4.
Yeah, cause I thought it would be like 3.04, sorry, I worded it wrong.
Okay, so we did a bunch of that. If you need a little more review, then look at the rest of that and the one below it. But we're doing something a little different. So now we're noticing that 10% is the same as 1 scoot to the left. If I want to say, what is 10% of 12? All I have to do is 1 scoot left,
1.1 dollar.
my 2. Why is that true? Because 2 scoots left was 1%. And make things into percent format, then this is 10 of those. So it would be like doing 2 scoots left to put it into percent format and then 1 back the other way. Cause I have 10 of them. And every
Okay,
time
I'm
we
just
do,
putting it into like, instead of like a percentage note into like the decimal node.
yes, this is going. This is very different than what we just reviewed, because we're not going in or out of percent, we're just finding percent of a number. So when do we want to find 10% of a number at restaurants? Not so much anymore, because people have calculators, and often today the tip, the receipt that they give you when it's time to pay for your food, it has, here's how much for different size tips. But so you're not reliant on that. We could do the same thing here. So mimic what I just did. What's 10% of $35?
Half of
Let me pull everyone for it. Oh, maybe.
$5.
No, it's just 1 decimal point scoot left. So take the 35,
350.
350. So if the service wasn't great and you wanted only a 10% tip, that would be 350. See how that
Once it's
works?
been off, you're only gonna give them $3.50 for a tip.
Actually, 350 sounds pretty good of a tip, honestly. Or I mean, the standard at least.
Yeah, the standard supposedly is 15% if it's normal service, 10% if something was a little iffy and really liked the service. At least that's what I was taught. Okay, what if you wanted to find 20% of something? Well, we just found 10% by scooting the decimal once to make it 3.5, right? So 20% would be 2 10%.
7.
20. So if I make another copy, 350 and 350. That would give me a 20% tip. So if I really had good service, then that would be a $7 tip. On the other hand, if it was completely normal service, and I'm going by the rule of 15%, then I'm going to take the $3.50. And then I'm gonna add 5%, because 10 and 5 makes 15. So what's 5% of 35? Well, this is 10% here, so 5% is half of that.
Half of that?
It's half of it. Well, half of $3 is $1.50. Half of the 50 cents is a quarter. And then put the $1.50 and the quarter together and I get $1.75.
175?
I add up the 10% number and the 5% number to get a 15% number, which would be 4, 5, 25 if I did my mental.
If both percentages are going towards the same thing, it should be like 10% plus 15%.
Yeah, so we're not. Yeah, this is just kind of a reminder, the percentages down below of what we're doing.
Okay.
So there, ta-da, there's your brain warm up for today. It's not really what we're doing as a math topic. But now you can estimate tips in restaurants, especially if you're stingy and doing 10%, and it's easy, just do the decimal point one.
My brain says it doesn't wanna be warmed up, it's tired and it's been up. It's been at work since 9 o'clock this morning.
Okay, on really to our next topic. So an elementary school teacher asks her students, what type of animal makes the best pet? And, oops, that I should take away. Okay. Each student was allowed one reply, so they all pick an animal, whatever they want. And then she made this image below because she hasn't taken my math class. So this is a colorful but terribly confusing picture. That has 5 kids, but the 5 kids don't mean anything. It's not like there were 5 kids in the class or 5 common answers or anything. That's just a clip art she found. And she in real life let each kid pick one animal, whereas in the clip art, now each kid is shouting 4 or 5 animal names. And we can't even see like what's really popular. How many students picked cat? It asks in green below the picture. I have to kind of play where is Waldo? How many cats are there? So let's count them together. So, whoops, let's lock that so I'm not moving it. Okay, so cats. 1, 2, 3, 4, 5, 6. That's it. Okay, 6 people picked cat.
Wait, does the answer count?
There's the word cat and the answer?
Yeah.
No. Okay, so this might look pretty on the wall if you like garish colors, but it's not really a useful way to display this information. So we're gonna be math people and pick something that's not as colorful, but displays the information much more clearly. And that's called a frequency table. So I have 2 columns. In one column, I put what is the thing? Animals, right? And the other column, I put how many people pick that thing. And since it's a primary election day, you can imagine that you'll see a lot of these in the news tomorrow. Of how many people were for each candidate and how many votes they got. And all kinds of cases where one column is the things and the other column is how many picked that or voted for that, or how many copies of that, or something like that. So a frequency table. It's not as cute as the other picture, but it tells us the answers we want a lot easier. Okay, let's answer these blue questions. How many students picked 4-legged animals, which would include the cats, not the fish, not the birds, the horses, the dog, and the unicorn.
Fishing and bird does not have 4 legs.
Right, fish and birds don't have 4 legs. So how many students picked cats, horses, dogs, or unicorn?
Wait, what?
How many students picked 4-legged animals, the cat, horse, dog, or unicorn?
13?
13. Everyone see how Gavin got that? Added up
Yeah.
these numbers? Could you imagine trying to answer that when all you had was that? More awkward. Okay, we could even write it as a fraction. How many students were there total? So 13, and then we're going to add 5 more. To get 18, 19, 20, 21, so 13 out of 21.
I didn't add the 2. I didn't add the 2.
Not sure, 6 and 4 and 2 and 1, that's 13.
Yeah, there's 21.
So 13 out of 21, so we
Yeah,
could write it
no,
like
yeah,
that.
You're right, sorry, I just.
And as a percentage. We talked back on one of those other slides, how do you turn a fraction into a percent? You do top divided by bottom. And then Riplop, oops, bottom. And since we're going into percent format, we're going to do the rip part of Riplop right into percent. So what is
All right,
13?
it looks like you're saying west.
13 divided by 21, so about 0.62 if I'm rounding. So about 0.62, and then I'll go right into percent. And this is 62%. Okay, you'll have to do this on homework. Questions about frequency tables. We have 3 different things happening. One is just counting. That was easy. The other is counting twice, because we have to put the total on the bottom. You could also, some people like the word whole instead of total.
Whole just means complete. Complete.
And then percent, you have to remember to take the fraction, do top divided by bottom. That gives you a decimal. Use the calculator, don't do long division, there are better things to do in your life. And then scoop twice to the right and put a percent sign on the end. Okay. What happens if I take my frequency table and I rotate it? So instead of it being that way, I turn it sideways. Then, okay. Then instead of just having the numbers, I'm gonna make colorful bars that go up as much as that number. So that's this picture. So I've taken the frequency table and made it into a bar chart. And you've seen bar charts before. Bar charts make it a little slower for questions like we just did. How many 4-legged animals? Well, I would have to look. And say, oh, well, the cats count and there's 6, not the fish, not the birds. The horse, yeah, that's a 2 where it hits the axis. Dogs count, that's a 4. And unicorns count, that's a 1, and then add those all up and get 13. So it slows us down a little bit if we want actual numbers. But for comparisons, this is the best of all. So what animals were the top 3 picks? I don't even have to know the numbers. I don't care that cat was 6. I just look at the thing and say, what are the 3 highest bars? That would be cat, that's the very highest, and bird, and dog. How many more students picked birds compared to horses? So now I'm saying the bird level is up here, the horse level is down there, and I'm going down 1, 2, 3. So 3 more students picked birds compared to horses. I don't even
There's
have,
more birds than dogs.
I
That's
don't-
the saddest thing ever.
I don't even have to know how many birds or horses there were, I just have to see that the tops are 3 different. So, the moral of the story is frequency tables are useful sometimes, and bar charts are useful also. Kind of for slightly different things.
I think bar charts are better for like a. Meetings for revenue. They're easy to understand, this. I would say like, graph charts are easier. Like the ones that go like
For change over time,
yeah,
but that's not what we're doing. We're not saying how these numbers change, we're just saying at one moment, we counted a bunch of things. And how do they compare?
yeah, but if you want to plan, you're gonna have to know those.
Yeah, but you're changing the topic, so that's, you could also tell me your favorite ice cream, but that's also changing the topic, so stay on top.
Else I told you how to make favorite ice cream.
Oh,
You have to do math.
oh, yes, but that's okay, we don't get to make ice cream, because that would make the Zoom people sad. Okay, we did top divided by bottom to change fractions to decimals a moment ago, let me just grab that. Shift Windows S. So now we're gonna have you do that a lot, because if anything is gonna mess you up on the homework, it's that you haven't practiced top divided by bottom. It's not hard, but let's have you practice that more. So all of these, the bottom is going to be the same, the 21, as there's 21 students. And all your job is to say 6 divided by 21 is 0.29, so that's gonna be 29%. And then someone can grab this one and move it away and say, yes, 29%, right? So do the others, all of them, divide it by 21. Scoot the decimal point twice and then move the purple rectangle that shows the worth. Oh, do you want me to just assign names to different ones?
My screen wasn't ready. Being driving to the.
Ready to the thing, okay, okay, well, let's have Gavin do fish. I should capitalize your name, be polite, okay, whoops. Gavin, Cody and Sean. And do the bird. Nicole can do the horse. Betty does the dog, and is Emily still with us? Yes, Emily is still with us. Emily, you do the unicorn. So find the percentage and then move your rectangle out of the way to check your word. When you have it, just call it out or type it in the text chat or something like that, and I'll put it on the board for you.
Okay.
Or you could make a text box if you want to be fancy, but you don't have to, that's okay.
Like
You
what?
do your square.
I was reading the numbers.
If you want to write your own number, you could just use a text box to type it,
Okay,
but you don't have to, I can write what you call out.
So what am I, fish here?
can I do?
You are
Remember the
bird,
bird?
you are 5 out of 21, change 5 over 21 into a percent.
Which one should we do?
Well, I added it with the 5 and not the 3. Can I?
No. Looks like someone moved the whole thing down, maybe it's 18. No, so this part up. Oh, okay, that's a lot there.
Okay, I did mine.
You did yours, so you revealed the answer, is 19% what you got?
Yes, that's 19% and it's a 0.19 on the scenario.
So you did 4 out of 21. And
Yeah.
got 19 and squared it in what?
Yeah, sorry about that.
We're on the same, I have no. We're good.
Okay, did you get 0.24 and then?
Yeah.
square-
Yeah, it's right just, it's right behind the Evans.
Yeah. Oh, I see, very down, yep,
Yeah, I chased Dan. You told me to send.
okay, Gavin, Nicole, Emily, what percents do you get for yours? Nicole can kind of cheat, since we're studying for the GED test. She's looking for 2 out of 21, but we already can see on the screen 4 out of 21. So she could just take half of the 4 answer, does that make sense, Nicole?
I think we lost Nicole, we only had.
She was just moving her mouse. So she's supposed to do 2 out of 21. So we could do that the long way. 2 divided by 21. And get,
0.95.
yeah, so scoot the decimal twice and get about 9.5, because the decimal would be right there. So it's about 9.5%. But she could also take half of the 19, because 2 has half as many as the 4 votes. So, and then Emily can now cheat, she can take half of 9.5. I don't have that kind of calculator.
4%.
Yeah, so 4 or 5, depends on how you round. Gavin, he could do half of the 6 to go from 6 to 3, so 29. Half of that is about 15-ish. 14-ish, depends on how.
I was gonna say 13, but I guess it's 14.
Well, officially, let's see, 3 out of 21. Is 14.3. So 14
I don't have
is
a calculator, I found.
Okay, everyone okay with this? You could do it more on homework?
Yes.
Make a fraction where the top is whatever is in your frequency.
I'm sorry, can you go over it one more time? I was making dinner and trying to pay attention and it didn't work out for me.
That's okay. So you were doing the 2. So that was
Okay.
the top number, 2 over, and the bottom is always 21, because that's how many students voted. So you could write.
Because that's how many what?
Students voted on their favorite animal. So you
Okay.
could write 2 over 21 as a fraction. The question is, after you did that, how do you make it a percentage? What people call the relative frequency. And to do that, 2 over 21, you could, that was this row here, 2 divided by 21, top divided by bottom, and then you scoot the decimal point twice. Oops, I want to highlight it, I want to scoot it. So imagine where the cursor is, right? You scooted once, twice, we're about 9.5%.
9.5%, okay.
So whoever made this rounded it a little badly, they should have rounded up instead of down. So that's the process, write it as a fraction. This is the count on top. The total on the bottom of all the different things counted. then do top divided by bottom. And then ripple up it right into percent, 2 scoops to the right. Relative frequency people like, because you can just sort of look at it and say, out of 100, how many people did these things? And you don't care how many people were surveyed or voted or picked their animal or whatever. The fact that we had 21 students to work with was really awkward. Dividing by 21 is friendly. You need a calculator for that. But if you could say 29%, you look at that and say, yeah, it's about 30%. It's about 3 out of 10 wanted that. It's a friendly little thing, it's percents, because it gives you the same sort of weight, no matter how many people were included in the
You made them.
counting. Whereas this 6, I don't know what that 6 means until I total up it. Is that 6 votes for cats out of 12 students? 6 out of 1,000 students? I don't know. If it's 6 out of 12, that's a whole half of them that like cats.
I know, let's go, but
So
that's
the
what I'm.
1,000, then this is the anti-cat.
Vinny, make sure you're watching something appropriate.
He didn't know, it's kind of like a love story at first.
It's not on mute.
Okay, you keep close, come back. So move this to open. There we go. Okay, the relative frequency
Actually, something else.
also allows us to solve other word problems. So there'll be something for sure on the GED, like these kinds of problems. So when I have percent of something, that was a slide we did up above, then I'm gonna take the percent and then of means multiply.
And this is this.
So I'm going to multiply the percent, the other number in the word problem.
Okay. Yep. You can't watch TV 14 or 13, that means it's not your age group, okay?
Here, I can just mute, cool, that's, okay. Let's see. Okay. So the other thing is I can't put the percents in the calculator well. Calculators don't handle percentages, so we're going to use not the right into percent, but the left out of percent this time to change these into decimals, so we'll have something to multiply by. So instead of 29%, we're going to use 0.29. Instead of 14%, we're going to use 0.14. Okay, tell me the other 4. What does 24% turn into?
0.24.
0.24, yeah, 9%. This is the tricky one because we're gonna have to go off into space when we scoot.
0.09.
0.09, everyone see where we got that 0 from? No. Because if I scoot left twice, then I run off kind of into space and I have to put a 0 there as a placeholder. Okay, 19%,
0.19.
0.19, and then 5% is gonna work like the 9%.
0 or 0.095.
At 0, okay, so that's what we're gonna multiply by as needed. Okay, the green problem. The elementary school class has a morning pet fact shared at the start of each school day. There are 80 school days. How many days should have cat facts to fit with the students' votes? So I want to find 29% of 80. So that's going to turn into 0.29. Of turns into multiply, and 80. So that's not hard, that's the calculator's problem, not mine. So it is 0.29 times 80, about 23, more or less. So instead of equals, I should say it's about equal to 23 cat fact days. Everyone okay with that example problem?
Yeah,
Yes.
Okay, so you'll do the blue one. They also have photos of pets decorating a wall. We want to find out of the 35 photos, the right percentage for cats. So cats is still 29%. So what's my next step going to be?
multiplying,
Yeah, 0.29
29, yeah. Times 35,
times 35. It's probably gonna round again. Let's see what it is. 0.29 times
times
35.
15,
10.15.
10.15. Okay, so we'll round to about 10 cat photos, because I'm not going to cut a cat photo into small little bits. I mean, I guess you could, that's just a little morbid for elementary school. Okay. And as a fundraiser, they're making sugar cookies. Each student makes cookies shaped like their choice of pet. There's 252 cookies. Now we're doing dogs. So what percent goes with dogs?
um,
You're just reading it off the chart.
21,
No, up here, dog row.
oh, dog, okay. 19,
19%. So again, we can't put the percent into the calculator well, so we'll do that log, make it 0.19 times 252. And whatever that is the calculator's work, I done. So 0.19 times 252 gives me about 48. I'm gonna round down because maybe they didn't make an extra cookie. Yeah, probably there's not enough dough for the cookie cutter to quite be full, so the kid just keeps that one, plus one. Okay, so this is a very common kind of thing. Someone will give you a frequency table. Maybe the problem will be polite and give you the relative frequency. If they don't, that's okay, because you know how to get the relative frequency yourself by doing top divided by bottom on these fractions. And then once you have the relative frequency, you can use it to solve this kind of word problem. What is the right percent of a number? Whatever the other number in the paragraph is. Okay, that was a lot of new stuff. Do you want to go on for another 10 minutes till 7, or do you want to take a brain break now? Brain
this
break?
was even more.
Why don't I put the next warm-up thing on the board and
Well, the next one's his birthday, March, April, May, June.
okay, so I'll see you in 5 minutes. If you want to play with this, you can. And stretch, eat, move, do something. I will stop the recording. Oh, okay. Somebody decided to make a bar chart that looked like water. Lots of April birthdays. So this time we have the bar chart instead of a frequency table. And the height is how many students had a birthday in that month. And obviously, this is just part of the answer because there'd be months other than these 4, but this is what fits on the slide.
So technically, many students had their birthday in the month of April, oh, that's.
Okay, so it would be 8 in April. See why it's 8?
So let me So let me see, 1, 2, 3, 4, 5, 6, 7, 8. 8 students had a birthday in April.
Right, okay, so your job, Jody, is to move the water squares around. Cause water is not gonna really stack up like that, right? We're not allowed to have a spike or a wave. So move it so that you get a nice even level of water everywhere. In all 4 columns. So take that top April one and move it to March or June to help the water seep the same level.
Oh, so there's like 2 students that had a birthday in March and 1 student that had a birthday in June.
Yeah, but let's make the water level, find the average. So grab this one here. And then move it down lower.
Move that one to March or June.
Yep, either way, doesn't
Okay,
matter.
equal, okay, I will move that
Just
to,
repeatedly take the up high water and make it more even.
Alright,
and
okay, got pancakes, anybody want some?
I'm good. You have asparagus, slap it on this. There. Good.
Figure here.
thanks, anybody, I'm busy right now. Should I take it all
Yep,
of
one
it out
more.
in April or then put it on March and June or no?
You wanna make the water as flat as possible, and it's gonna work out to be flat this time, so you have one more to move. From too high to level.
Oh, what, May? Oh, this one.
It all now the
Got it.
water is flat, okay, so what you just did is you found the average. Okay, so what's the average is when everything sort of flows together and evens out. So how tall is this average? 1, 2, 3, 4. So we have an average of 4 birthdays. That makes sense?
And then the average of birthdays in April is 1, 2, 3, 4. And then the average of birthdays in March is 1, 2, 3, 4.
There we go.
So no one will ever again give you a bar chart with nice easy pieces to rearrange. So we need to find a different way to get the average when you don't have a nice chart to play with. So that is our new task.
So technically that was easy, but now we gotta find something to make it hard on me.
Okay, so first we're just gonna talk a bit. We have pattern blocks. I can go in my office and grab some if you want. And they come in several shapes. The green one is small. 2 greens make a blue. 3 greens make a red. And 6 greens make a yellow. And actually, yeah, I'm gonna go grab some to play with. So just pause or eat or something
Okay,
and turn this off for now.
it looks like there's 7 left. Okay.
Abajo. Cierras el cuadro y tú le aperturas a la esquinita esta y así te miras tú solo la prima y miras a todos.
I would just do that on my own, did I get that right? While you were over there playing the pancake monster.
Waiting on it.
Okay, so come over here. we have a scale. And that is a little.
That's a tiny scale.
We have a scale and we want it to be in grams. So the green triangle is the smallest, play with these. 2 greens make a blue. 2 greens make a blue. How many greens make a red? Build a joint, how many greens make a red?
3.
3. So. And then how many greens make it yellow? 6. It's about through a little rounding that a green is 1.5. If I do 6, then it's about 9. The scale is perfect. Okay. So here's my question for you. Now that you've seen these things, let's make that group on the left. So 2 greens to the left side, 1 red. And 6 blues. 1, 2, 3, 4, 5, 6. So you're wondering, what is the average, not average, what is the typical weight of a block in this group? And there's not one answer, because the English word typical is a little imprecise.
So we can fill out those grants now and change recording again. Please. Sorry, yeah, but it's just getting recorded here to me now, which does fair.
5.5.
Thanks, Claudia.
There's like,
So total is about 26. But we don't want the total, we want the typical weight of a block.
I get scored very easily, thanks.
So is red what you're counting as the typical block? No, there's only 1 red, that doesn't sound like typical.
Think blue.
So 1 blue is about 3.
I'm around. Since he's like, writing not there. So,
Imagine that we had a group of people and we're saying, what's the typical weight of one of the people? You're not gonna put 3 people on the scale at once. That would be a way to measure the typical weight of one person.
you know, 3 skills. Play the same.
So this is a weird question, and what makes it weird is some people focus on what happens the most often. They say in this group, the thing that's the most often is blue. So the typical weight of 1 block will be how much a blue weighs. So if that was you, you could take a check mark and say, that's how I like to think of it. Other people say, well, I'm gonna look at these blocks. And anything that just doesn't appear often enough to count as typical is disqualified. And I'm gonna toss it out. So I'm gonna toss out the red, because there's only 1 of them. And I'm gonna toss out the greens, because there's only 2 of them. And that still leaves the blues as the typical, but we got there in a different way, rather than saying what's there the most of. We said, let's disqualify some things. So if that was you, you could copy the check mark and put it here. And then some people remember something from a math class and they add up everything. And they say the total weight of this whole group is 26. And then we count how many blocks are in the group. So how many blocks are in the group over here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 26 divided by 9, and whatever that is, I don't really care what it is. But that process tells me the typical weight of one block. So some people could say, yes, that's how I think about it. Does it make sense that all three of those are defensible ways of using the word typical? And if I say, what's a typical income in this neighborhood? What's a typical grade in this class? What's a typical amount of water that people drink and using in a year? All of those, you could say, well, what's the most common answer? You could say, let's throw out and disqualify things that don't seem typical. Or we could add everything up and divide by how many. We could do the same thing with a different group. So now somebody added 2 yellow blocks. And we could again talk about what's typical. And the same issues would appear. Everyone with me so far? Okay, but we're in a math class. So we need a right answer. That's how math works. So the most often, or the throw out things that don't appear often enough, those lead to arguments. Right? What if 2 people are running for president and they get the same number of votes?
Lead to arguments.
Right, so we're gonna pick the third one, because it's a math class. So when we say, what's the average? We're going to add up everything and then divide by how many. And that's not that it's more right than the other definitions of typical, but it's the math one, so we call that one the average and not the others.
Okay. Okay,
So there's your little kind of English language history. Now let's do a example. So there's a preschool classroom. There's a bunch of students. Let's count together how many students. It tells you, but let's pretend it doesn't tell us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 students in the room. And here are their weights in pounds. The lightest student is 34 pounds. The heaviest is 41. And besides that list, you've been given a bar chart that has the same information. So what's the average weight of those 12 students? So we're just gonna add up all those numbers, and then whatever that total is, divide by 12. So somebody with a calculator, or you could click on here and see the Desmos calculator. Add up all those numbers and tell me what the total is. And then,
Where do you, where do you find that there's 12 students?
where do I find there's 12? Because we counted them. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, okay,
10, 11, 12.
okay.
And also some the next sentence. But on the GED, it's not gonna be polite and tell you
if you
that.
look the right thing, that's hoping it's in the way.
The GED is gonna make you count them yourself.
I was always told, growing up, you have to leave stuff out and then sing it.
I got 37.5.
What was the total first?
37.75. So 37 would be,
What was the total though of all of the numbers?
37.5.
That must be the average. Or total is.
Yes.
big number.
Oh,
Oh, it was 453.
453, so we did 453 divided by 12, and we got
Yes.
about 37, I'm gonna round up to 38 pounds. So there's two ways to think about this. Remember what Jody did with the water? You could picture that someone chops apart the bar graph and makes it level. And that kind of thing.
So
Or-
question, do you always have to round up, or why couldn't you just leave it at 37?
30, it was 0.5, you said, and I'm trusting you on that.
please.
It was 37.75.
0.5,
Okay.
so then I'm rounding up to 38. Cause the 7 makes this 7 makes that 7 go up by 1.
Oh, I see. So depending on what the third number would be, would depend on whether you round it up.
Yeah, so to
That
round
7,
the
okay,
whole
that makes
number.
sense.
That makes sense. And I could leave the answer as 37.75 pounds, that's technically correct. But that's not how we talked about the weights to start with.
Right.
So sort of following, whoever asked this problem is thinking of whole number weights. So I'm kind of entering their worldview and saying, yeah, let's use whole number weights. The
Okay,
other
that
way
makes
to think about this is if I made a teeter-totter, a balance scale, it's saying that it's gonna balance at 37.75. Does that look like this would balance, that the weights on this side are about the same as the weights on this side?
No, look, well, yeah,
Maybe I should put the triangle a little more over like that way.
no.
So people are pretty good at this, kind of looking at where the balance point is. Right, this bar is short, but it's way the far over, so it's gonna exert more force on the teeter-totter, so on. So if you've played with these things, we're pretty good at just seeing about where the average is by looking on the chart. So again, homework is gonna ask you to do this. It's not hard, you add up the numbers, let the calculator do the work, and then divide by how many. On the GED, it's multiple choice, so you don't even have to worry about how to round it, because it's gonna be one of the numbers. Okay, now there's a problem. What we did is called the average, usually. Even more officially, it's called the mean, MEAN. It doesn't mean it's unfriendly. It's just that math people stole the normal English word and used it wrong. Sometimes the mean is not appropriate. So let's take the same classroom with 12 students. And now 3 of them said, wait, I have my stuffed animals. 2 of them weigh a pound. The other stuffed animal is a little heavier and weighs 2 pounds, and they should count too. Let's include them in the weights. So if I do that, the total weight is gonna go up by 4 pounds. Everyone see why? 1, 2, 3, 4.
Mhm.
So the total weight is now gonna change from 453 to 457. And instead of dividing by 12, now we have 15 friends in our sample. Everyone okay with how I changed those numbers because of the stuffed animals? So 457 divided by 15. Now gives me about 30 pounds, 0.4, I'll round down just to make it 30. And that's a terrible answer, because if I looked at that chart, nobody weighs about 30 pounds. Right, 30 on my chart would be over here, 33, 32, 31, so here's 30. The students all weigh more. The stuffed animals all weigh less. So now our mean, our add them up and divide by how many kind of average, that mean gives us a stupid, useless number. It's not what anyone would call typical of anything in the room. It doesn't represent anyone. It's just mathy. So we need a different kind of way to find an average in that situation. And what you do is what's called the median. To find the median, you list them in order and then pick the middle number. So we had 1, 1, 2, and then 34, 36, 37, and so on, right? So we
Right.
list them in order, and now we have to find the middle number. So cross out U and U. Cross out U and U. We're working our way towards the middle by crossing out the outside numbers. So now the middle number is 37, so that is our median. So that's more representative of something, not of the 3 stuffed animals, but it shows us the weight of the students a lot more fairly. Yes, it's typical of now something in the room. The students, even if it's not inclusive of the stuffed animals. So medians happen whenever this situation is present in real life. There are some things that are either way too small or way too big. And when we say what's typical of these numbers, we don't want to count them. So if Chloe has living in this neighborhood, all the houses are about the same, and Bill Gates moves in and builds a giant mansion, then what's the typical house value in the neighborhood? Maybe they went up a little bit because of all the tourists wanting to see Bill Gates's house. But in
Instead of
general,
Chloe's house.
in general, it's not like her house has gotten any better just because Bill Gates moved into the other side of the neighborhood. So we should make a list of the house values and cross out the outside ones, which will ignore Bill Gates. And then find a more representative number. Similarly, if you're wondering what the average income is of people that write movie scripts, most of them don't write anything during any year. It's a job they do some years and not others. So if you were to list out all of the movie script incomes, the first half are gonna be zeros. And that's not the question you're asking. You're asking, if I sell a movie script, about what do I get? So when you cross out all of the numbers, starting on the outside and working towards the middle, then you'll get kind of the low end of the ones that sold a movie script that year. Then you'll say, okay, I get a little bit of money. Right? If it's not like I got the most money for selling the movie script for the top movie of the year, it's not like I got 0 money because I didn't try this year. Somewhere in the middle of the list. So whenever there's things that just are too big or too small and throwing what is typical off, then we use the median instead. You can think of the median as ignoring the most extreme values. And if you've heard of a bell curve, because it's shaped sort of like a bell you would ring. If it's symmetrical, the mean and median line up in the middle. If it's not symmetrical, then wherever the hump is, pulls the median in that direction a little bit. So if the hump is on the left, the median becomes smaller than the mean, things like that. Any questions about that?
No.
No.
Now, there's one other word that textbooks include just by tradition called mode. And mode just means who wins the election, what number has most things. So if we were to look for the weights of the kids, then 36 is the mode, because 3 of them had that. But most math class applications, you don't care about popularity. That's different than a math class. So which one gets the most examples of it? Then that's kind of coincidence that 3 kids are 36. That's not an interesting question. So we don't really use the mode, but the textbook always includes it with kind of traditional reasons. So you'll see mean, median, and mode, that's what the mode is. it's an election day, we should talk about votes, because voting for the tick and matters in real life, just not in a math class.
Yeah. So you want one to not, really,
So one math class, real life only overlaps sometimes, especially in a GED class. If you were doing something practical math class or culinary arts, then we would do a lot more food and a lot less of lean media and mode. But to study for a test, sometimes you just have to know vocab. Okay, any questions about this? Do you want to stop and look at the textbook and do some homework problems? Or do you want to go on with more thinking on the whiteboard?
Let's do a little bit more.
Keep going with this? Okay.
Yeah.
I'm not doing very many example problems of any kind, so I am trusting that this is good enough and you could watch the video or whatever if you get stuck. Okay, we've dealt with counting, taking the frequency tables and getting the percentage, that thing we call the relative frequency, the other column. That involves counting. Now we're gonna do something else called probability and odds, so you can all bet on horse races. Or something. First, we're gonna practice counting. These are more of a tricky puzzle than a real math thing. So Oscar owns two kinds of socks. There's kind of a black and red pattern and a black and yellow pattern on his white socks. His sock drawer has 6 pairs of each kind. So 6 pairs means 12 socks are in his drawer. So he's gonna reach in and get out a sock. And he's gonna reach in again and get out another sock. How many times does he have to take one sock out of his drawer to be sure he gets a matching pair? It's not twice, because he could get a red and a yellow and they don't match.
Let's see. So I have 6. We will map. In the word, like 6 pairs of. It says. His sock drawer has 6 pairs of each kind.
Right, so this picture only has 1 pair of each, but he has 6 of those copies, stuff that's already. So the answer for how many socks he has to take out to be sure to get a pair, it's not 2, because that could be 1 red and 1 yellow. Does he need 3 or 4 or 5? How many socks does he have to take out to be really?
3.
3. Why do you say 3?
Because either 2 of them has to be the same color.
Yeah, if the first 2 don't match, the third has to match one of those 2. Does that make sense?
That does.
So 3 picks will be enough. He doesn't have to pick 4. A lot of people will say 4 for this.
Yeah, I was like, I thought one, I say something about basis academy, the third one makes time.
Okay. Next similar problem. A box of the cereal Sussy Oats has one of 12 different collectible crewmate toys. How many boxes must be opened if you want to be sure to have a pair of matching toys? Your kids are gonna fight if they don't get the same thing. You love this cereal. How many boxes of cereal are you gonna eat to be sure that your kids get matching stocking stuffers for Christmas?
That's 2. That is true.
That is pretty.
It's not any more tricky than the one we just did.
So can open box, yeah. Looks like the gold release.
6.
See, there's 12 different ones.
Oh, 12 different
So
collectibles.
then it has to be more than 12, because if you open 12, you could get really unlucky and have no matches yet.
And how many boxes must be open with? Get a pair and once you put. 4. And then again, I don't know exactly. Too complicated, that I can.
Chew with your mouth closed, please.
But again, it's all done, but what most much. Okay.
Is it 24, I wonder?
No, you don't need to eat 24 boxes of cereal, it's a smaller thing than that.
And one of them free, right? Man. So, two better. I don't get that, but.
I'm gonna say probably 4.
So if you're really unlucky, you can open 12 boxes and not get any match, because there's 12 different toys. What happens the next time you open a box of cereal?
There'll be none.
Always has a toy in it,
Will be a different one.
But it could match the previous one.
it has to match one of the previous ones, because you've seen them all already, right?
Yeah, you're like,
Yeah.
12.
So you need,
So 13.
so you need 13, Jody got it.
Oh,
So-
she beat me to it. Dang
If you are really unlucky and none of the first 12 match, the 13
Beat me up on it.
will have to match
I didn't
one
think
of
about it,
those
like,
12, because you have already seen them. Is that an okay way to put it?
Yeah.
yeah,
Okay. So you're good at counting, and we can talk about probability.
Okay.
So, pretty picture, the probability of a situation is a ratio, is written like a fraction, of the desirable outcomes. Desirable because the question is asking you about them, not because you yourself care about them when you desire them. And it's usually written as an.
can we mute the board, please, cause it's kind of hard to hear you when there's the noise in the background.
Well, yes, I can mute Nicole, she can unmute if she wants. Written as an unreduced fraction or it's changed into percent format. So let's do an example. If I roll 2 dice, then I get this chart up above. If you haven't seen this kind of chart, it's a little confusing. Let's talk about why there are 2 3s here. I could roll 2 dice and they could add up to 3. I could roll a 2 on this die. And a 1 on that die. And that adds up to 3. Or I could roll a 2 on the other die. And a 1 on the first die, and that also adds up to 3. And if the dice are the same color, then in our minds, those tend to blend together. But they're really 2 different things. And if the dice were 2 different colors, it would be obvious that they were 2 different ways to roll.
Okay,
Are you with me so far?
Yeah,
okay.
So how many ways could I roll a 4? I could roll a 3 and a 1. I could roll a 1 and a 3. Or I could roll a 2 and a 2. There's 3 ways to roll a 4.
Okay.
Everyone okay with how this chart works?
Sure.
So we have 2 problems, a green one about 7s, and I've highlighted all the 7s and greens for you. And there is a pinky red one with 10s. So what's the probability that the sum is 7? So on the top, we have what we're calling the desired ones, the ones that this situation cares about.
so going across.
So
with
how
the
many
seven,
green
just like
7s
take
are on
pictures.
this table?
6.
6. Everyone see what Sean saw?
Yes,
1, 2, 3, 4, 5, 6. So that's the number on top. And then what's the total number of numbers on the table? 6 and 6. So 6 times 6, length times width.
Some, was like 36, I thought.
Yeah.
Thirty, I was gonna say 36.
6 times 6 is 36.
So 36 chances, so,
Yeah,
so 6 out of 36 chances, and you still get 6.
it's, you could reduce it, but we're not doing that right.
Okay, so, just all.
You don't want to reduce it, because then the real life situation changes. We're not counting 1 out of 6 things. We're counting 6 out of 36 things. So you lose that real life context. if you-
Oh, so you're doing the probability,
Yeah. Oh, okay. How about 10? What's the probability of the sum being a 10? So how many pinks are there?
1, 2,
3, and there's still 36
so.
on the whole chart. So 3 out of 36. Everyone okay with that kind of counting?
mhm.
Now, English is sloppy.
Okay.
There's something different called odds. You've probably met people that use the words probability and odds as the same, but they don't actually mean the same thing. So let's talk about how to use them correctly. So odds is a different kind of ratio. Now on the top, we have the same thing. How many fit the situation we're talking about? And on the bottom is everything else. So the odds of 7, there's 6 of them that were 7s, same as before.
Yeah.
Everything else, I have to take the 36 and remove these 6. So now I am counting these and those. So 36 minus 6 is 30 that I just sort of made triangles on. Okay. So 6 out of 30 is the odds. It's a different ratio. And this is why we're calling them ratios and not fractions, because fractions are always part over whole. But now this bottom number isn't how many are in the whole chart. It's smaller than that, because we subtracted some away. So a ratio looks like a fraction, but you don't have the limitation of the bottom being full. Cool. Okay, what are the odds of the sum being 10? There's still 3 10s on the top. What's 36 minus the 3?
33.
33, yeah. So that's one set of answers. In probability, going back a little bit, then often we want a percent. Just like with the fact that with the kids and their pet choices, we don't really care that there was 21 kids. We just want to know, is it like 50% or 30% or so on? Then often with probability, we'll change them into percents. We'll say, what is 6 divided by 36? And that's about 17. If I scoot the decimal over, 16.6 rounds up to 17. And I think I'm actually going to screen snip that so that we have it for later.
Now you made it so dark.
That's just to help me draw the rectangle. So we had that, and then with Riplop, we did bump, bump. Does that help make it look more complete?
Pretty much.
Yes.
Okay, for 3 out of 36, same thing. 3 out of 36, it's gonna be half as much, by the way. So we've done our top divided by bottom, we did this a bunch before break. And then we're going to go right into percent and get about 8.3%. So about 8%. So the probabilities, you have either an unreduced fraction or you have a percent. That's the two ways to write each by tradition. Somebody might on a test say reduce it and then do their instructions. But that's kind of weird, because again, we're losing track of what we really counted in real life. So odds are about like betting on horses. And when people say the odds, they never want a percent. Instead, they want you to find the ratio and then pretend it's a fraction and reduce it. So we haven't really done this yet in class, but we could say top and bottom are both multiples of 6. So this would become 6 divided by 6 is 1, 30 divided by 6 is 5. For this one, top and bottom are both multiples of 3. 3 divided by 3 is 1. 33 divided by 3 is 11. And with odds, you'll often see that the fraction bar is written as 2. So the odds are 1 to 11, or the odds are 1 to 5. And people who use odds want to bet on things and gamble, so they want the numbers small so they can do the math in their head well. They don't care that it used to be 33, they just want 11 because that's easier to do math with. So now you know pretty much all there is about probability or odds. It's just counting, but how you write the fraction and what you're expected to do with it are different. Okay. If your brain isn't full, there's one more detail, which is that people are often wanting to know about the probability or the odds for groups of things together. So not just rolling a 7, but maybe rolling an even number. So a collection of outcomes that we group together is called an event. So what's the probability of the event that we roll an even number? So we have to count all the evens on the chart. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9,
10,
10, 11, 12, 13, 14, 15, 16, 17, 18 even numbers out of all 36. Or the odds would be 18 even, and then 36 minus that 18 is also 18. So this could be called 1-to-1 odds if you reduce it. We could also say, what is the probability of, erase all these, getting 8 or more? Okay, so let's count with me all the ways to get 8 or more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of the 36, or 8 or more. And then 15, what's 36 minus 15?
it's 15.
No, 36 minus 15. 21. Don't be afraid to use the calculator. You're allowed to on the GED test.
21.
So 15 to 21. So this is 15 out of 36. This is 15 to 21. They're different things. One is part over whole and the other isn't.
Okay.
Mm-hmm.
Okay. If you want some fun homework, then here's a game. You could take a piece of paper like this, cut it out, fold it, tape it together and make a box. And then you have a weird die with 6 sides And you can have spaceship explosions and bombs. And you can play the blow up other people's spaceship game. Maybe good if you have kids at home who are violent, like blowing up spaceships. And do some problems with that. We're gonna skip this one now. This is more of just like at home if you care thing. But you can ask about probability or how to change this to make it even more exciting. Cool. Okay, remember the sock puzzle and the cereal puzzle from our warm-up?
Yeah,
So the GED will often do that along with probability or odds. So maybe the problem gives you this sort of picture. These are all the ways to get red, green, and blue gumballs out of a gumball machine. The gumball machine only has those three colors. And it has the same amount of all the different colors. So it's just kind of random what you get. So maybe you could get red, red, and red. Or maybe you get red, red, and green. Or maybe you get red, red, and blue, and so on. And these are all the different combos. On a timed GED test, it's not going to ask you to draw this table yourself. There are some tricks about how to do this efficiently, but you don't care. But it might give you a table like this.
Okay.
And then ask a question like, how likely is it to get at least one blue gumball? So let's all count. Tell me, I'm gonna move the mouse. Tell me when to circle something because it has at least one blue.
Go circle that one.
This one,
and then circle,
one, and then all the rest of that row, okay.
and then down here, circle this one too.
The whole bottom row is all circled, right?
Yeah.
Yeah,
That's the blue in the middle row, so. Okay, we're skipping over some in the here, so this one is circle.
that one right there,
This one.
and that one, and then the one,
Okay, so how many of these were there? 1, 2, 3,
Three,
4, 5,
5,
6,
6,
7,
7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19.
So 19 out of, how many are there total? 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. What's 3 times 9?
17.
7. So 19 out of 27. Same as we just did before, but a little more complicated just because of how this table is asked. But you could do this, right? It's not hard once you've seen it. Okay, now you are ready for homework. If we go on more, then the next thing we're doing is our measurement topic. So we did all of the counting and mean, median, mode and frequency tables and relative frequency and probability and odds. This was an immensely busy math class. So I know it's Tuesday, you won't have time to do a lot of homework before Thursday, but maybe try and squeeze in some time to do at least a little bit looking at the textbook example problems or something, so that you get stuff put into long-term memory. Because if you just listen to me and watch me and then don't do it yourself, it's all gonna drift away.
I get it now. And the one was the sock and the circle, I started like, huh? And then you showed me how to do that, it's, oh, I see now.
Yeah, there's a lot of tricks. If you want the book of math tricks, if you like that kind of thing, then is Aha Insight by Martin Gardner. Have I shown you this one this term? I don't remember.
I think you have.
I think I have to.
No, Chloe's right, you haven't shown that towards this term.
So don't pay too much for it. It's out of print, so it's all used bookstores. Sometimes you can get a copy for like $4 on Amazon.
Okay.
But this is the library of cool math tricks. If you like hanging out at cocktail parties and acting smart, then this gives you all of the tricks ever.
Okay, cool.
Okay, thank you for your awakeness and attention, and I will see you Thursday and we can talk about measurement instead of counting and fractions.
Oh, that was kind of fun, I mean, I was like, I was seeing what you're trying to see, and. Oh, I get it now. He's giving us something.